Okay, so let's look at the second heat and thermodynamics question in the Get It series. Let's read. A quantity of an ideal gas at 10 degrees Celsius and 300 kilopascals occupies a volume of 2.5 cubic meters. If the pressure is raised to 300 kilopascals and the temperature is raised to 30 degrees, the new volume of the gas is closest to. Okay, so if we say, well, the pressure went from 100 to 300, so that should triple, so it shrinks it by a third. But the temperature went from 10 to 30, that triples, so that should raise it by 3. So then it should stay the same, so it actually should be 2.5 cubic meters. But we look here and we see that that one's close to 2.5 cubic meters, but it's not. And that's because we're not horrible here. We try not to be, okay? My error is to say that 10 degrees to 30 degrees is a tripling. It's not really, because temperatures in this formula that we use, PV equals nRT, temperatures there are in Kelvin. In other words, that is 283 Kelvin and this is 303 Kelvin. So the temperature has not tripled, right? So therefore, really the temperature's increased just a little bit and the pressure has tripled. So the volume will be roughly a third of what it was before. So a third of 2.5 is about 0.8. So that one's a bit over that. So go to 0.8 by pressure and then expand a little bit by increasing the temperature. So this is likely to be the answer. We can do the actual calculation from here. We can rearrange this, so say V equals nRT over P. So therefore we got to multiply by 303 over 283 for the temperature, and we've got to divide by 3 over 1 for the pressure, and we just do the calculation. 303 divide 283 divide brackets 3 divide 1 close brackets equals, we get 0.35689, times that by the initial volume, and we get 0.892, and so B is the answer, and then B is the answer. So that is a nice easy question, and as I say, we aren't interested in tricking you in this sort of question. That's why 2.5 cubic meters is not one of the answers there. What we hope is if you get 2.5, you think, oops, I've done something wrong because it's not in the answers, let me have a look, and then you go, of course, its temperature's supposed to be in Kelvin. What percent got it right? Last year, about 88% got it right. And option D, this one, the one that was closest if you were actually thinking that 30 was 3 times 10 in Kelvin, that one had about 7% chose that, and the rest were all negligible. Okay.